My topic is how to calculate the height and weight metal consumed in the welding. So this, you can see this figure, V group butt joint. So here this is the T, thickness of this plate, the height of the bead, this is the width of the bead, this is the group angle. The group angle you will be take the 60 to 90 degree. The group angle are generally depends upon the thickness of the plate. So up to the 6 mm, no need of any the group. The more than 6 mm thickness, the group angle will be the need. So the angle of this group will be depends upon the thickness of the plate, and also you will take the 60 to 90 degree. This is the RG, root gap, this is a root length and a root face, and this is the plate thickness, this is the width of this weld bead, or H is equal to height of the weld bead. So how to calculate the height of this bead? The height of this bead is also called the reinforcement of the weld deposit material. So using this formula to calculate the height of the bead, to W into H divided by 2, to RG into the thickness of this plate T. Here you can see this figure, W into H divided by 2 into T into R. So H is equal to T into R into 2 divided by W. W means width of this weld bead. And how to calculate this weight, this cavity? The weight, this cavity, area into density into length into the 1 by E. The area is calculated by this formula. So RG into RL plus T into RL का square into tan theta by 2. So theta value is here 60 degree. So you can calculate this area by this use of this formula. So weight, the area into density into L. Density, so density means density gram per centimeter square. So iron, when you are use the mild steel, then you will be use this density 7.87, copper 8.94, 304 stainless steel 7.92, 204 stainless steel 7.90. The carbon steel containing the carbon percent 0, the steel percent 0.25% carbon, then you will be take the density 7.86. This is the E. This is the E. So L means the length of this bead. L is the length of this bead. Here, length of this bead like this. This is the L. L is the length of this bead. E is the deposition efficiency. The deposition of efficiency means it is the ratio of this. It is the ratio of the filler metal to the metal is consumed in this cavity. The deposition efficiency is a number which tell us the welding machine give the high well good efficiency to deposit the metal in this cavity. So if the number is increased, it means that the filler metal is consumed in a low level. So here, so for the value of E, arc welding, so 55% means 0.55. So for the value of E, TIG welding and MIG welding 95%, 0.95. So submerged arc welding for the value of E, submerged arc welding 100%. So it means that the number is increased. So that you can say that the deposition of this material is properly or completely and very low level. So you can this figure. This is the single transverse. This figure is like this. This figure is like this. So this is the weld height. This is the weld height, and this is the weld bead. This is the width of this bead, or this is the weld bead height. This is the weld bead height, and it is the V group butt joint. This is the V group butt joint. This figure is like this. This figure is like this. This is this plate, and this is also second plate, and it is also called the single transverse lap joint. Single transverse lap joint. Here, this figure, this portion is called the reinforcement or welded deposit area, draw a line at perpendicular to the AC, then you will calculate the the third thickness T, the S into sin 45. So S means the leg of this, length of this bead, and you will call the leg. So T is equal to S into sin 45. Sin 45 0.707 S. The A is the third thickness. This is the air. This is the third thickness. The A. The A is equal to T into L. L means this is the length of bead, like this, length of this bead. So the value of T is put in here, so 0.707 S into the L. So you can calculate this formula into A. So the thickness of the plate may be the equal or may not be equal. So may not be the equal, then you will find the area is equal to half into base into height into base into height. This is the base and this is the height. Then you will calculate this formula A for the not for the equal thickness of this plate and also equal of this plate, then also use this formula. So here A is the L into T into L. The L is the length of the weld, S is the size of the weld portion, W means the weight. So weight same is formula A into density into L into 1 by E. The extra material, this is the area is the weight. This formula is weight is here, only this figure. So this is the extra material. Extra material means reinforcement. Then this 20% of this weight are added to calculate this total weight of this figure. So for design engineer and production engineer, have the sound knowledge about the how much metal are deposit, how much take the bead height deposit this material, and also save the material to perform this welding, and avoid the different type of the inclusion, corrosion, porosity, and also defect of the hardness to deposit the material. The height of the bead you will take the more than 3 mm, you will take the 3 mm the height of this bead. So I hope that different type of the this type of the joint and this type of the joint, are generally used for the making different type of the structures and automobile chassis, and this type of the welded are generally used for the different type of the automobile parts, industries parts, and general purpose. How to calculate the height of the bead and weight of this metal, consumed metal, different type of the formula are used to calculate the height of the bead, area, and weight of the consumed in this cavity. I hope that you will like my lecture. Thank you very much.